Haripriya, did you solve this question? Hello, 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 hello. Hello, Haripriya, am I audible?
Sir,
Mhm.
I didn't get
Okay, solve it quickly till the time others are joining. Then we'll start permutation and combination then.
Sir, option B.
Option D, na?
No, 4.
4 now. Okay, okay. Yes, yes, yes. 4 is only the answer actually.
I just had to substitute.
It was easy only. This IIT, those early these years questions in 1998, 99, they were actually easy.
They didn't have to make it difficult.
Correct. Actually, during those periods now, the craze of IITs were not that much. Because that time it was actually prestigious to get into IITs, but people were getting jobs. They used to get jobs easily without getting into IITs also. The mid period only, the crisis when the IT sector job were not there, no? In the mid period only there was crisis, so the craze of getting into IITs has become very high. But nowadays also the students who are not even getting into IITs, they are getting good packages and all. So, but still the values of IIT is still there. IIT as a degree itself is a very respectable thing. See, permutation and combination. Permutation and combination, Haripriya, what is that? Actually, no one is having what? Everyone is having exams to do. See, permutation means what? Permutation is arrangement. And combination, later which you will study, is selecting. Permutation means arrangement. Haripriya, when are your exams going to start? Those
9th October.
9th October, no? Okay. And what about your syllabus? It's completed. How much of
It will be completed by December. Physics, I
syllabus?
think physics is completed till gravitation.
Yeah, they have completed gravitation. Rotation,
Yeah, but
SHM also.
system of particles.
Hmm.
One track is system of particles. The other teacher is doing thermodynamics now.
It's a thermodynamics is also doing.
No, not thermodynamics. The
Okay.
chapter before thermodynamics.
A chapter before thermodynamics.
Thermal and matter something.
Thermal properties of matter. Conductivity, convection, those things. But they're moving very
He
fast.
just
Hmm.
he just started that.
They're
We
going.
have two tracks now, sir, so it will be covered quickly.
What is the, even though if they're covering very quickly, you will be practicing only one topic, na, in one day. You'll be solving questions of one day, one topic only.
No, if we have both physics tracks today in the timetable, we'll do both topics.
No. They will do both topics. You will do both topics in the class, but after class, when you come to your home, you have to do. You will be doing one. You will be practicing question of one topic only, na.
Yes, sir.
You
We cannot manage books.
see the crux is what, na. It's managing thing. Crux is important thing is how much you are able to practice. How fastly they cover or I cover doesn't matter. What matters is how efficiently you are doing the problems. You are able to solve the problem. How efficiently you are managing your practice. That is important. Because see what happens, they will cover fastly. You in the class you will understand. But since you are not able to manage time for practicing both the topics, again you will complete one. You will go for the, when you will come to the other one, they would have completed it earlier. Then you will have to revise it again. So instead of that, it's much easier for the students if they cover one topic, 2 3 tracks. See what is permutation. Suppose there are a number of things, A, B, C, D, E, F. These things, 1 2 3 4 5 6 things are there. Now, what is permutation? See, permutation is all kinds of arrangement. This is counted as one. Now, if you arrange F with E, E with D like this, you will arrange them each in each places in all possible ways. Means suppose one case is F is placed in the position of A has been placed in the position of F. This is one arrangement, rest all things are same. Other arrangement is A and B are interchanged. Other arrangement is A and C are interchanged. Other arrangement is B and C are interchanged. All those possible ways of arrangements is known as permutation. Okay. Now, how do we denote it? How do we find this arrangement? These ways, keep just put boxes in each place. This. Actually, in mathematics, how do we calculate these arrangements? Total number of arrangements. There are 6 things. 1, 2, 3, 4, 5, 6. All 6 are different. Now, when you can place all 6 things, any one out of these 6 things, any one thing, in what ways? 6 ways, no? Correct?
Yes.
Either by A, B, C, D, or E, or F. Now, after you have placed any one thing out of them, suppose you have chosen B and you have kept it here. 1 is engaged, B is engaged. Rest all things are how many? There are 5 things. So you can put, I'll just write it. Rest all now are 5 ways, because 6 already one thing is engaged. Now 5 out of 5 I can place any one thing. Similarly here 4, 3, 2, 1. And when I count all that arrangements, what I do? 6 into 5 into 4 into 3 into 2 into 1. This is known as 6 factorial. Okay? Means, in short, total number of arrangements possible with these 6 different letters is 6 factorial. Multiply this, all this 6, 5, 4, 3, 2, 1, you'll get a number value which shows the total number of possible arrangement of words, so that you will frame different words. These. Understood? Haripriya, okay?
Yes.
Now, acha, Diva, I have just started the basic things. These things I think you may be knowing already. I have just told permutation is nothing but an arrangement. Okay, these things you know. 6 factorial things you know. How to represent a factorial?
Yes, I know.
Okay, this is one factorial. Now, permutation is arrangement. And similarly, what is a combination is, let me tell you about combination also. Combination is the number of ways of selecting things. I'll give you an example. Suppose you have A, B, C, D, E, F. You have 6 different objects. Out of this, I have told you, Haripriya or Diva, you have to select any 2 objects out of these 6. In how many ways you can select? See, the number of ways, if we try to see, the number of ways can be either I select A and B, or I select B and C, or I select C and D, or I select D and E, or I select E and F, or I can select A and C, B and D. Means each selection of 2 objects represents a way. Okay, there are many different possibilities which you can easily identify here. So these all possibilities represent the different ways of selecting 2 things out of these 6 different things. In mathematics, what they say, number of ways of selecting are things out of n things is equal to NCR, which is n factorial divided by r factorial into n minus r factorial. This is very important definition. Here, what I said, this is a formula. Number of ways in which you can select r things out of n things. General formula. Now, in this case, I have told you, you have to select two objects out of 6 objects. Number of ways will be 6c2, which is 6 factorial divided by 2 factorial into 6 minus 2 factorial. Same formula. So it will be 6 factorial divided by 2 factorial into 4 factorial, which is, now I'll calculate it. See how I do this one. 6 factorial I can write as 1 into 2 into 3 into 4 into 5 into 6. 2 factorial I can write as 1 into 2. 4 factorial I can write as 1, 2, 3, 4. Now for the simplicity, what I can do, I can cancel these out. Now it will become 5 into 6 divided by 1 into 2. 2 3 is a 6, 5 3 is a 15. So the number of selections of 2 objects out of these 6 different objects I can do in 15 ways. I have counted now 1, 2, 3, 4, 5, 6, 7, 8, 9. Also other possibilities are there which I did not show. 9. Again you can select B with E also, B with F also. Those all possibilities are there. All those selection possibilities are 15 possibilities. This represents a combination. Okay. Now don't get confused, it's easy one. I'm just giving you the basic things. Gradually I'll make it easy. I'll explain you the easier concept, then you will understand it properly. Just remember these formulas, the formula that I've told you, the important. This one you have to remember. Don't go deeper, otherwise if you go much deeper it will become more confusing. Permutation combination. Gradually you should go deeper, gradually, once you understand. Now what is permutation? Permutation is this one arrangement, and I'll give you one formula for this also. Number of ways of arranging R things out of n different things is NPR. Means what we are doing? We are actually taking R things out of n things, and then we are rearranging them in all possible ways. Like we have arranged these 6 objects now in all possible ways. We got 6 factorial. Here what we are doing, out of n different things, first we are selecting R different things, and then selected R different things are getting rearranged in all the possible ways. This is NPR. The formula is n factorial by n minus R factorial. See, how do we do it? The NPR, this I can calculate in the way, first selecting R things out of n things. I have selected R things out of n different things. After selection, I am rearranging them in all rearranging these R things in all possible ways so that I am getting all arrangements. So I'll multiply R factorial with this. I should get this one, NPR. If you see, if you put in the formula, you'll get NPR only. So NPR is nothing but NCR into R factorial. Understood? Are you able to understand? Is it confusing or not? What? Confusing or okay?
So it's fine.
It's fine now. What about Haripriya? For Diva, it will be fine up till now.
It's fine, sir.
Because Diva has got somewhat idea. It's totally new to Haripriya. Both are okay? Then okay. Now see, You have understood the basic these formulas, basic permutation, basic combination. Now let me tell you the fundamental principle of counting. It's very important. Actually, sometimes this fundamental principle of counting they actually skip. And because of this alone, students get confused. It's that important in permutation combination. Fundamental principle of counting consists of only two things. One is addition principle and other is multiplication principle. There is no division principle. There are only two principles of counting. No division principle, no subtracting principle, because according to them the subtracting principle should not exist, because there is nothing we subtract in when we are calculating the arrangement or this one subtraction or this one combinations. Nothing we subtract, and there are no negative values also we do not get. Similarly, in multiplication principle, they say the division principle does not exist, because division principle won't come into picture. Whenever it comes, you have to treat it as a multiplication principle only by taking the other thing as reciprocal. Other thing as the reciprocal. One is you are dividing two things. Take one thing as one, other thing as the reciprocal of the original thing. So it again becomes a multiplication. So that's why they say division does not exist. Now, what is addition principle? Here, whenever you will be applying the permutation combination principles to the mathematics, you will actually be reading the theory, or you will be applying the things that you see during the calculation. Means, like, suppose I see device doing the homework, device solving problem, Haripriya is solving problem. When I'm talking about this thing, you both, I'll say it in two different ways. One way is device solving problem and Haripriya is solving problem. What's the meaning of this? The meaning of this is device also solving problem at her home. Haripriya is also solving a problem at her home. Both are solving problem at her home. So when I'm talking about solving problems among the students, Diva and Haripriya both are solving problems. This is the meaning of and. You both understand. Now, when I'm talking about, when in any statement I'm using this and as a term, that means what? I have to use multiplication. Okay, like I have given you one example in this way. Let me give you the example in the way we have discussed this one. NPR. What I have said, number of ways of arranging R things out of N things. There were N different things. 1, 2, 3, 4, N different things were there. Out of that, I have to arrange R things. So what was my working? I have selected R different objects. You can start from 1 or you can start from 2, but you have to select any R objects out of N things and different objects. That can be done in NCR ways. This represents selecting R things out of N things. Correct? Now, when I have selected these R things, now I have to rearrange them. So after I have selected R things, 1, 2, 3, 4 up to R, now I have to rearrange them in all possible ways, which is R factorial. Now my work of arranging R things out of N things get completed only when I select R things out of N things and then I rearrange them. I'm using AND here. Arrange R things out of N things means selecting, first process is selecting R objects out of N objects and rearranging R objects among themselves. So I am using here AND. By using AND only my work gets completed. Otherwise it won't, because both of them has to complete. This has to complete, that has to complete, then only my full work will be completed. I am using AND. That's why I am, when I'm calculating this is NCR, this is R factorial, and when I'm completing this whole work, arranging R things out of N things, I am multiplying them, NCR into R factorial. That's why my answer becomes this one. So what I say, when how I'm using, which language you are using in mathematics, and where AND comes, whenever you are using AND, whenever your total work get completed by using your AND sentence, and in the sentence, then there you have to apply multiplication. Okay, understood?
Yes,
Viva?
sir. Yes, sir.
Okay. Now coming to addition principle. What is addition principle? Addition meaning, whenever we use addition in the mathematics or in the permutation combination, that means in the normal language we will be using OR. What's the meaning of this? I have taken the original example, device solving problem, Haripriya is solving problem. Here I am writing OR now. What's the meaning of this OR? Diva is solving problem or Haripriya is solving problem. It means what? Either Diva is solving problem or Haripriya is solving problem. We do not know who is solving problem. Any one of them should be solving. When I'm saying this, I don't know whether Diva is solving problem. If Diva is not solving, Haripriya should be solving problem. Both cannot be solving problem at the same time. Any one of them is solving. Don't know who is solving. So in that case, we use or, and whenever we use or in our sentence, that is addition we do. Okay, that's how the calculations is done. Understood?
Yes, sir.
Now, let me give you a question on this addition principle. Hmm. Try solving this.
Sir, option A.
Option A. Let me check. Correct. What about you, Haripriya?
I don't know where I've gone wrong.
Acha. Let me show you how we solve it. See what the question says. In a monthly test, the teacher decides there will be 3 questions, one from each of the exercise 7, 8, and 9 of the textbook. There are 12 questions in exercise 7. Acha. He has to select one question from each of 7, 8, and 9 of the textbook. 12 question in exercise 7, 18 in exercise 8, and 9 in exercise 9. Acha, see, he has to select. Let me write
Sir,
using
I found out how many questions from each section.
how many ways.
How many selections from each section? I don't know what to do after that.
Acha, tell me how many selections you have done.
12 in 7, 18 in 8, 9 in 9.
Correct. See, now comes your principle of counting. So, in exercise 7, from exercise 7, you have to select one question, which can be done in 12 C1 ways. And from exercise, what I'm writing, what is the spelling? Eight, 18. So one question can be selected in 18 C1 ways. Similarly, from exercise 9, you can select one question in 9 C1 ways. Now see, when teacher is framing the test, his test will be made comprising of these 3 questions. One question from each exercise, right? So in a test of 3 question test, his 3 question test can be made by using question 1 and question 2 and question 3, right?
Yes.
Question 1 from this, question 2 from this, question 3 from this. Or in other ways also, you can use either you can take question 1 from exercise 8 or question 1 from exercise 9 in whatever ways. Okay, now. So this end is there, and so you have to use multiplication principle. So it will be 12 C1 into 18 C1 into 9 C1.
Sir, I got it. It's 19.
1944. Actually, I still think there is some mistake. Acha, he did. Acha, no, okay. He did not differentiate between the questions. No? Question 1 can be from anything. That's no problem. See, understood? Now coming to the next one. Acha, see, the arrangements, this is how we apply the fundamental principle of counting. Understood now? This is how we are applying under fundamental principle of counting. Haripriya?
Yes.
Because DY is comfortable with it now, till now. Now, when I was saying this one, number of ways of selecting things, in this way, NPR ways or the NCR ways, this stands only when we are arranging things na, like this. I have told you there are 6 things, so you have to be arranging in 6 factorial ways. How I said 6 ways, 5 ways, 4 ways, 3 ways, 2 ways, one way. This type of arrangement holds only when permutation, we are talking about permutation without repetition. Now, what is the meaning of this without repetition? Without repetition is means when I have explained it to you, once I have selected one B and put it in this box, that can be done in 6 ways, either using A, B, C, D, E, or F. But after that, what was my reasoning? After I have put the B in box 1, I cannot put same letter B in the second box. That's the meaning of without repetition. Okay. Haripriya, Diva, okay?
Yes.
But
Yes.
when we are talking about repetition, we are means in a situation they have said there is a repetition allowed. Now with repetition, what things will be? Means once we have used B, again we can use B again. Means the first letter in this particular case, what will happen? B first box, the first letter can be put in 6 ways. Again, the second box again, because B is again available. So that can be done in 6 ways again. So in the third place also it can be done in 6 ways. So 6 into 6 into 6, 6 into 6 into 6. How many ways we can arrange? 6 power 6. That is the difference between without repetition with repetition. Without repetition, when you are arranging, you get factorial. With repetition, you are arranging means you get 6 power 6. Okay. Clear? I think this is clear. This is the easy part. Now, let's solve the next question. Don't worry, I won't give you very tough question now until I'm sure that you have grasped the concept. Try solving this one. Eva, these kinds of questions only you were sending to me on during the doubt period.
Sir, I was facing problem in which
Then
we have to consider multiple cases. In those kind of problems I get stuck.
if you still get stuck now, send them to me. I'll take those type of questions only earlier. You understood those questions now, which I gave that time, solved that time?
Sir, C.
Hmm. Okay. Diva, what about you? Solved?
So I'm still going.
Do it. After this, try solving this one. If you still face problem here, I'll solve it. Not a problem. How it will be solved? It's actually easy. NP4 by NP5, which is n factorial by n minus 4 factorial. It's n factorial by n minus 5 factorial. This will get cancelled. It is 1 by 2. Now n minus 5 factorial by n minus 4 factorial is this. Now see, there is one important thing here. This is n minus 5 factorial. n minus 4 factorial I can write as n minus 4 into n minus 5 factorial. But I think Haripriya did not solve like this. Haripriya just substituted the numbers options, right, Haripriya?
No, sir, I said.
She solved it, other than very good. Because most of the students, what they do now, when they come to this point, they find it difficult to cancel like this. So they just put the number values or options that are given, and then they'll see. What the thing is, see, what I'm using here, I'm writing n minus 5 into n minus 4, sorry, n minus 4 factorial I'm writing as n minus 4 into n minus 5 factorial. How? It's like we can write 6 factorial as 6 into 5 into 4 into 3 into 2 into 1. Na? But these things I can write as 6 into 5 factorial. It's like that. N minus 5 is actually smaller than n minus 4. So I can write n minus 4 factorial is equal to n minus 4 into n minus 5 factorial. Diva, okay? I know you will be facing difficulty here only. So this one, remember n minus 5 is smaller than n minus 4. So you can always write like this. I'll give you a general formula you can use for solving question. N factorial is equal to n into n minus 1 factorial. Here you can put n according to your convenience. That's why we are getting 6. Now try to solve the next one.
60 ways.
Okay, 60 ways. Correct. Very good. Diva, okay.
Yes, sir, I'm getting 60.
60, na? It's just NP3. Formula application only you have to do. Try this.
Sir, is the letters repeating?
Letters, no. Letters are not repeating.
Sir, A.
Hmm.
Sir, A.
Correct. Hmm. by solving this. B.
A.
Okay. Quick. Let me check which is the correct one. A. Shiva,
Is
you
this
are getting. Check it again. Answer should be A.
I go wrong in this when both combination and permutations are given.
And because I'm gradually making your concept strong, is understanding stronger. Later, I'll give you the difficult part. Okay, na? Do you need me to solve it?
Yes,
Diva?
no problem.
No, na? हो गया ना? ठीक है. अच्छा, ये वाला क्वेश्चन और सॉल्व कर लो. Gradually, I'll increase the difficulty.
So D. The C.
T is correct, Priva. T is wrong.
So initially I was getting 1380, but then I thought that when we will do internal arrangement, then we will get more numbers.
Internal arrangements, how? How many numbers can you, which are greater than 3000s? How did you do it? Just send me your working.
Okay.
Greater than 3000 means your first digit should be 3. Either 3 or 4 or 5.
3, 4, or
You
5.
can, first digit should be 3 or 4 or 5. 4 digit numbers. Acha. See, you can have 3 cases, either 4 digit or 5 digit or 6 digit, right? So now I'm solving. Later I'll check your this one. Let me solve it. 4 digits are there. So 4 digits. These you can solve. This can be placed in 3 ways: 3, 4, or 5. And these 3 out of any numbers, now one number that you have used 1, 2, 3, 4, 5, 6. So the repetition is not allowed. So this you can do in these 3. You can fill in 5p3.
Can I leave?
Huh? You can leave.
Thank you,
So
sir.
it,
Bye, sir.
okay, it will be 3 into 5p3. Okay, Diva. Now what about 5 digits? 5 digits number will be 6p5 minus 5p5. Let me see your working.
I've written it in very low way, so if there is any step, you can ask me. I'll explain.
Okay. Case 1, case 2, and case 3. What is your case 1? Case 1 is acha.
4 digit, then 5 digit.
3 into 5p3 you are getting. 180 ways. How did you get it? 3 into 5 factorial by 2 factorial. 3, 4, 5 into 3. 180 you are getting. Correct only. 5. Second is what? 5 digit.
Yes, so 5 digit.
6 digit. Acha, you did not take that case now.
So till the end, I'm getting the right answer 1380. But after that, I thought some other logic, and then I thought and that.
No. Other which case you thought?
So I thought that like when we are taking like जैसे फर्स्ट उसमें 5 ऑप्शंस हैं, सो आई थॉट लाइक उसके बाद जो हमारा नंबर आएगा मैंने उसमें ही परम्यूटेशन और कर दी, लाइक तो एक्स्ट्रा केसेस ऐड करने के सो गया.
नहीं, क्योंकि कोई कोई केस मिस ही नहीं हुआ ना.
यस
कोई केस
हाँ.
मिस ही नहीं हुआ. तुम करेक्ट सॉल्व किया था. कंफ्यूज ही हो रहे हो. क्योंकि देखो, मैं सोच रहा था कि तुम लोगों को कंफ्यूजन पता है कहाँ होगा. क्योंकि सेकंड वाले स्टेप में जिसमें तुमने 5 डिजिट लिया है, तो उसमें 5 जैसे 5 डिजिट वाला लिया है तुमने वाला केस, तो 5 डिजिट में तुम पता नहीं तुम लोग काउंट करोगे कि नहीं. वो वाला केस जिसमें पहले 0 आ जाएगा, पर तुमने तो पहले लिया ही नहीं है 0, क्योंकि 5 नंबर ही काउंट किए ना. 1, 2, 3 या 4, 5, उसमें से 5 ही नंबर. 0 तुमने लिया ही नहीं, तो वो 4, क्योंकि 0 जब बनता तो वो 4 डिजिट नंबर बन जाता. ठीक है ना. वो करेक्ट लिया है तुमने. ऐसे ही जब तुमने 6 डिजिट नंबर लिए हैं, तो 6 डिजिट नंबर में भी तुमने वो पहले 5 लिया है, तो वो करेक्ट तो किया है। प्रॉब्लम ये होती है बच्चों के साथ कि वो 6 ले लेते हैं यहाँ पे, इधर। सही सॉल्व किया है तुमने एकदम, ठीक है।
Yes, sir. और मैं वो एक्स्ट्रा केसेस का ध्यान रखूंगी। आई थिंक हर क्वेश्चन में ये मिस्टेक हो रही है।
तुम ऐसा किया करो, अगर तुम्हें ऐसा कुछ लगता है ना कि और एक्स्ट्रा केसेस बन रहे हैं, तो वो एक्स्ट्रा केसेस, और अगर तुम्हारा आंसर करेक्ट है तो वो एक्स्ट्रा केसेस जो तुम सोच रहे हो वो मुझे मैसेज कर दिया करो, मैं तुम्हें बता दूंगा कि वो वाला केस क्यों पॉसिबल नहीं है। ऐसे कंफ्यूज, ऐसे जब तुम क्लियरली सोचोगे ना तो फिर तुम्हारे आंसर्स करेक्ट आएंगे। वैसे ये भी तुमने एकदम करेक्टली सॉल्व किया है, एक्स्ट्रा ओवर थिंक कर लिया, ठीक है। क्योंकि देखो, जब तुम इंटरनल अरेंजमेंट की बात कर रहे हो ना दीवा, जब तुम सोच रहे हो ना कि ये अंदर से इंटरनली अरेंज हो जाएंगे, तो जब तुमने यहाँ पे 5p3 लिया, जब यहाँ पर p लगा दिया, तो वो उसने अरेंजमेंट को टेक केयर कर लिया ना पहले ही।
हम्म,
अगर तुम c लेते 5c3, तो सिर्फ चूज करते, उसके बाद तुम्हें इनको इंटरनली अरेंज करने के लिए 3 फैक्टोरियल लगाना पड़ता। और जब आपने यहाँ पे 5p3 ले लिया, तो इसका मतलब आपने अरेंजमेंट को ही तो लिया है। तो फिर आपको अरेंज, फिर उसके बाद इंटरनल अरेंजमेंट के ऊपर के लिए घबराने की जरूरत क्या है, ठीक है। चलो फिर एंड करते हैं।
बाय सर।
बाय बाय। मैं धीरे धीरे और टफ क्वेश्चन दूंगा ग्रेजुअली, उसमें फिर कंफ्यूजन होगा, अभी तो ठीक है।